Hi everyone, so today we are going to study 74163 MSI device, which is a counter, and for that this is the IC. So I will just show you the IC. Here you can see there is a notch, and a notch is on top. There is no circle to confuse you, so notch always on the top, and this is how you should insert. So try to put number properly. This is a 8-pin IC, so it's not like your other 74 series IC. Since it's a MSI device, that is medium scale integration, it has many components on it, and this is going towards VLSI, that is very large scale integration. So basically this is a counter, and once you insert IC like this, pin number 1 on the top, it's a 8-pin IC, so you have to count up to 8, and then this becomes 9, and then go back to 16. So if you come to the pin configuration, the last pin 16 is VCC, so we will connect this pin particularly to VCC 5V, and this is the first connection you need to do. The next connection is ground, so we will choose a black wire for the grounding, and that goes to, if you see the connection diagram, this goes to pin number 8. So now pin number 8 over here, so pin number 8 goes to ground. So these are the two main connections we should always take care of. Now coming to the next pin, so let's go pin by pin wise. The first pin is I think it's called R, and that you have to control because it's a reset pin, or it is actually clearing the entire input section. So once you put this pin to 0, it will clear all the output you had previously. So I just put it to one of the control inputs, which I can control between 0 and 1. The next part is CP. Now CP is again a clock, so what I will do is I will try to connect a CP pin to a clock. Now there are two possible locations where you can give a clock. Here you can select a 1 Hz signal, so that you can see everything happening per second, and if you want everything to be controlled, you can put it to this particular location, and whenever you press, then the next state happens. But currently, since I am alone recording this, I would prefer it to put it to 1 Hz. And again you can put it to variable clock and control the speed of the operation. So that is about the next pin. Then you have 4 pins connected. These are the parallel inputs. So what happens is, you can select any counting starting point. Let's say I want to start this count with 0 1 1 0. Then I have to set the inputs, 4 inputs, and then it will start counting from 6, that is 0 1 1 0, and it will count up to 16 from that point. So let us do that. So I will now just connect all 4 of them to input, because I need to show you the demo. So first pin is P0, 0th bit is always going to 0, so that is the first connection. Next first bit, so here we go with the first pin, and that goes to pin number 1. The next pin is pin number 2, and that goes to here, and then the last pin, that is again what you can see going here. And as the number of wire increases, it becomes more and more confusing, but if you do it properly pin wise, it will be easy. So we have finished up to this P3 pin. Next is CEP. Now this is the enable pin, and that will be shorted with CET, and both will go to, since it's enable, we will put it to VCC. So let us short this CEP, and a pin exactly in front of it should go to VCC. So again what I will do is, I will put the next pin over here, So this is the pin, black color. This is one we are trying to connect. So this is ground and this is the pin CET next to the black color, sorry. And here is the other end. So now it needs to be shorted. So what I will do is I will connect something to CET, this pin exactly in front, and now what you have to do is short both of them. So two ways of shorting these pins. One is something like this, you can insert. The other way is, what you can do is put it like this and then you insert from the top. So I personally find this one is easier compared to the other. And then the other end should go to the VCC. So now the circuit is started becoming confusing, but go pin wise, it's always the best strategy. Next is PE pin. Now that is where you start the counting. So you have to again make this PE pin user control, so you can put it to user control. Then you have 4 outputs and then a carry flag, that is terminal count. So 5 outputs, so we need to connect everything at the output and then your final VCC. So that is the entire connection diagram. I will start connecting them one by one. So let us choose green, terminal count as the carry. Now I put it apart at pin number 9 to distinguish from the other counts, and then we will start with first pin. If you see, it is Q3, so I will put it to pin number 3. Again it's reverse, so the second pin is Q2 and now I have to put it to pin 2. Okay, next pin is, now it might be a bit difficult for you to see, but they are in order, just straight line wise. And hence the final connection, pin number 18 goes to pin number 0. So this is how the circuit is connected. Now let us try and start the circuit. Okay. Now you can see that there is no output, it's all cleared because my clear bar is at 0 and that's why output remains 0. Now also you can set this to some random 0 1 0 1, and now we have to find out when this state is transferred to the output. So here let us put this clock to high and you can see that the output is being transferred. Now it will start counting from this location, so 0 1 0 1, so that is 5. And now if I turn on the counting, so you will see that it should able to start counting from that location. So 6 7 8 9 10 11 12 13 14 15, and if you can see exactly on 15 the terminal count goes high for a moment and it will reset. So again we will just see it once more time. Okay, so this is how the circuit works. And if you want to start from some random position like this, again what you have to do is stop this and you will see that it got latched to 6, and if I enable it will start counting from 6. So this is how this circuit works. Thank you.